Okay, so I want to continue just looking at basic mathematical operations and loops in Java. So I thought we would create a program that calculates prime numbers because a lot of the Project Euler problems are about prime numbers, and it would be great to just have a kind of plug and play little function or method or reusable bit of code that calculates prime numbers that we can use over and over and over again. And it's a really good first programming task. So what I'm going to do is ask the program to calculate all the prime numbers up to some maximum, say all the ones up to 100, all the ones up to 1,000. Take a minute to think about how you would do that. If you want to pause the video and pull out a piece of paper and write out the pseudocode for what that would look like, going through all the numbers, checking to see if they were prime, what does it mean to be a prime number. Not necessarily writing out the Java code, but writing that out in what we call pseudocode. Those of you who maybe didn't take the class with me first semester, pseudocode is just a shorthand way of writing out an algorithm halfway between writing out sentences and writing out actual Java code or Python code or C code or whatever. It's just a way to get yourself started thinking through an algorithm. So what I'm going to do in the videos when we get to this point where I want you to think about it yourself, is I'm going to put up a little screen that encourages you to pause and think about it yourself. Obviously, I don't know if you've really paused the video and are thinking about it yourself, but I'm going to ask you to do that anyway. Okay, so did everybody think about how to calculate prime numbers? Maybe you did, maybe you didn't, but I'm going to do that anyway and encourage you to do so. We could go ahead and pseudocode that in our comments. This is one thing that I encourage people to do last semester, and I'm going to continue to encourage you to do as a way of documenting your thought process. What are the steps of finding prime numbers? You start counting from 1 or 2. You check to see if the number is divisible by 2, 3, 4, etc. If it is, then it's not prime. If you get through all the possible factors and don't find any, it is prime. So print out that number. Yeah, boy, that is terrible typing. This is why I've been copying and pasting instead of typing stuff out. And then go to the next number. So in order to code this, we're going to need 2 for loops. One for loop for checking all the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to whatever our maximum is. And then for each of those numbers, a for loop to check all the factors. Is it divisible by 2, divisible by 3, divisible by 4, 5, etc. So we're going to have a for loop inside of a for loop. What variables am I going to need? Let's go ahead and just declare our variables right now. I think the only variables we're going to need are integers, right? We're just checking numbers to see if they're divisible by some factors. So I'll need the current number that I'm checking. I'm just going to call number. And that's going to be an integer. So we have to tell Java, we have to declare that variable to be an integer. We need to know how high to go. What is the maximum number we want to look at? Let's call that number just max. And let's pick a value for max. Let's initialize max to be 100. And then every time you look at a number, we have to try a bunch of different factors. So let's call those factors that we're trying one at a time factor. Do we need to initialize it here? Not really. We'll initialize it in our for loop, so we can just declare it and not initialize it. And then for every number, I want to ask the question, is it prime? And if it's prime, I'll print it out. If it's not prime, I just go to the next number. So I'm going to create a Boolean type variable, just a true or false type variable. And I'm just going to call it, is it prime? And so if I find a factor, I can set is it prime equal to false. If you have factors, you're not prime. And I think that's all the variables I'll need to do this. So they're all declared, and the one that needs a value at the beginning is initialized. So what do we need? We need a for loop to test all the numbers from 2 or 3. We already know that 2 is prime. But I guess if we want to print all the primes, we should start at 2. All the way up to some maximum. So we'll have a for loop for all the numbers from 2 up to the maximum. So we're gonna do it like this. For number starting at 2, we don't have to start at 1. 1 is not considered a prime. All the way up to max, so for number starting at 2 until this is no longer true. So for all numbers less than or equal to our maximum, I've declared our maximum to be 100, but I could change this to 1,000 or 10,000 or 100,000. And every time I go through the loop, I increment the number by 1. So number plus plus says take that number and make it 1 bigger. And that's my for loop. And I'm going to go ahead and create my curly braces that start and end that for loop. And I'm going to go ahead and comment that one, end of outer for loop. So for each of these numbers from 2 all the way up to 100, what am I going to do? I'm going to try dividing it by all of the factors 2, 3, 4, 5, 6, 7, 8, 9 to see if it's divisible. So I'm going to use the modulo operator to see if it's divisible. So I need another for loop. I'm also going to assume at the start that every number is prime. So I'm going to take this variable, is it prime, this Boolean variable, and I'm going to give it the value of true. Notice that the true and false keywords in Java are lowercase. I think the true and false keywords in Python were capital. So a Boolean variable can have the value of true or the value of false, lowercase. So we're going to assume a number is prime until I find a factor. Okay. Let me collapse this sidebar for you guys so you can see a little more of the code. All right, so I need a for loop. What am I going to do? I'm going to start with the factor of 2 and check, is it divisible by 2, 3, 4, 5, 6, all the way up to the biggest number I have to. How high do I have to go? I don't have to go all the way up to the number, right? I can go up to half the number because you can't have once you get up to half the number, it might have, well, you can't have a number that's bigger than half of yourself, right? Because what would it be divisible by? Think about that for a second if you don't believe me. All your factors have to be less than half of yourself. So our for loop is going to look something like this. For factor starting from 2 and going up to the number, the current number divided by 2, the number I'm checking, right? And then every time I go through the loop, increment that factor by 1. So this ends my inner for loop. Okay, so I'm counting up from 2, 3, 4, 5, and I'm going to check to see if it's divisible. How do I check to see if it's divisible? If the number modulo the factor is equal to 0. That's equals. What? I got to do something. What do I do? I said, is it prime equal to false? Right? If I found a factor, then is it prime is now false. And once I find a factor, I don't need to keep checking anymore, so I can break out of the for loop. Okay? Let me say that again. Once I find a factor, if this is ever true, if the number divided by the current factor as I count up 2, 3, 4, 5, 6, is it divisible by 2, 3, 4? Once I find one, I know that the number isn't prime. So I call is it prime false. And the break kicks us out of whatever loop we are currently in, which is the for loop. So if I'm doing, I don't know, 15, for example, is it divisible by 2? No. Go to the next one. Is it divisible by 3? Yes. So it's not prime. So I don't need to check 4, 5, 6, 7, 8, 9, 10 because I found a factor. All you have to do is find one factor, and you know it's not prime. So if I find a factor, okay, found a factor, so it's not prime, I can break out of the inner loop. So the break statement kicks me out of whatever the innermost loop I'm in currently. So far all I've done is I've tested to see if the numbers are prime. Now I want to kind of report my results. So once I've checked all the factors, I can say if is it prime is equal to true. Let me put a little white space in here. Actually, let me put a little white space at the end. Okay. I've checked all the factors. I've gotten to the end of my loop. If is it prime equals, it still equals true. In other words, I didn't find a factor while checking, then just print out that number. Actually, let's print out that number plus is prime. Okay? And I need a space there. Space. I think we're done. I think that should work. Let's run it and see what happens. I would be surprised if I didn't miss a semicolon here or there, so we'll fix all that. I didn't. That's very unusual, actually, for me to make it even to the end of a short program without missing. Let's make sure it's right. 2, 3, 5, and 7, 11, 13, 15 is not, 17 is, 19 is, 21 is not. Yeah, so it works. So there's all the prime numbers up to 100. We go up to 1,000. Okay, 911, 927, 997. Okay. So what we have is sort of an algorithm here for finding prime numbers up to some value. We could make this algorithm into a function or a method so I can use it over and over and over again, and use it in any of the Project Euler problems that involve prime numbers, of which there are quite a few, actually. Anything else to say about this program? It was pretty easy. The next thing we might want to do is to take all those prime numbers and put them into, we might want to count them, like how many prime numbers are there up to 1,000. We could do that by just creating another integer variable called how many primes and adding to that every time we find one. We can also create a list of all the prime numbers that we can go back to anytime we want to find a number and see if it's prime. We did that last semester using lists in Python. Java can do that too, although it's a little different and a little more cumbersome. And we'll take a look at that in the next program.